Hello everyone and welcome to my channel Computer Classes by Rachna. Today we are going to talk all about binary trees and its types. So first of all, let's see this example of a binary tree. A binary tree, as it spells BINARY. So BI means 2. A binary tree is either empty or it has some nodes. And every node of a binary tree can have a maximum of 2 children, which means a node in a binary tree can have a 0 child, 1 child, or 2 children at the max. If it has 2 children, it has left and right child. As you can see in this example, A is the root of the tree, B is the left child of A, and C is the right child of A. Similarly, D and E are the left and right child of B, and G and H are the left and right child of C, and so on. T1 and T2, as marked in the example, are called as the left subtree of A and the right subtree of A. Now we talk about the levels in a binary tree. As you see the example, we have root at level 0, B and C at level 1, D, E, G, F at level 2, and so on. You can see K is at the last level, which is level number 4. And the depth of the tree, as you can see marked by the pointer, the depth of the T is basically 4 plus 1, which is last level number plus 1. And please see a note, the maximum number of nodes at any level L will be 2 raised to power L. Look at level number 1. 2 raised to power L means 2 raised to power 1, which is 2. So it has the maximum nodes B and C. Level number 2, 2 raised to power 2 equal to 4. It already has 4 nodes, which is D, E, G, and H. But if we talk about level number 3, it does not have maximum number of nodes because 2 raised to power 3 equal to 8, and it has only 3 nodes. Now we talk about another type of binary tree, which is a complete binary tree. As you can see in this diagram, this tree is an example of a complete binary tree. We have 1, which is the root of the tree. The left child of 1 is 2 and the right child of 1 is 3. Both of them are at level 1. Then we have the nodes as 4, 5, 6 and 7, which are at level 2. Then at level 3 we have 8, 9, 10, 11, 12, 13, 14 and 15. These are at level 3. At level 4 we have only 4 nodes, 16, 17, 18 and 19. Now let me tell you the definition of a complete binary tree. A complete binary tree is a tree which has all the levels complete except from the last one. That means all the levels except from the last one have maximum number of nodes, and the maximum number of nodes at every level is 2 raised to power L. So here in this example, all the levels starting from level 0, 1, 2 till 3, they all have the maximum number of nodes, but the last level do not have maximum number of nodes, whereas all its nodes are as far left as possible, which means there is no missing node between the first node and the last node of the last level. So let's look at level 0. 2 raised to power 0 is 1, so it has 1 node. Let's look at level 1. 2 raised to power 1 is 2. It has 2 nodes, which are 2 and 3 respectively. Level number 2 has 2 raised to power 2, 4 nodes, 4, 5, 6 and 7. Level number 3 has 8 nodes, 2 raised to power 3 equal to 8. Whereas level number 4, which is last level, it does not have 2 raised to power 4 equal to 16 nodes, but all the nodes which it has are complete. 16, 17, 18 and 19. There is no missing node. 8 has a left child and right child. 9 has a left child and a right child. And there is no missing node from 16 to 19. So this one is a complete binary tree. So we can revise it as follows. A binary tree that can have at most 2 children in each of its node. Any level L of T can have at most 2 raised to power L nodes. The tree is said to be complete if the following conditions are true. All its levels except the last one have the maximum number of possible nodes. All the nodes at the last level appear as far left as possible. So at the last level, no node is missing between the first and the last node of the last level. Thus, we can have a unique complete tree Tn which exists with exactly n nodes. So the above is an example of T19, exactly 19 nodes. Now we talk about another type of tree, which is a binary tree, and it is called as a binary search tree. There are two examples which I am showing on the screen, and they both are the examples of binary search tree. A binary search tree is again a tree which can have a maximum of 2 children. It does not have duplicate values, and it has condition which is followed every time by all its nodes, that a value which is lesser than node goes to the left side, and the value which is greater than node goes to its right side. So if we check the first example, 14 is less than 38, it goes to the left child of 38, and 56 is greater than 38, it goes to the right child of 38. 8 comes to the left of 14 and 23 to the right of 14, because 8 is less than 14 and 23 is greater than 14. Similarly, 18 goes to the left of 23 because it is less than 23. So this is an example of a binary search tree. Now let's see 70. 70, if I compare 70 with 38, it should go to the right of 38. So we move to the right child, which is 56. Now again, 70 is greater than 56. We move to the right child of 56, which is 82. Now 70 should come at the left of 82 because it is lesser than 56. So 70 comes to the left of 82. Now let's look at example number 2, which is alphabetical tree. Here, all the nodes which are alphabetically smaller than j comes to its left subtree, and all the nodes which are alphabetically greater than j comes to the right subtree. And the same procedure is followed for all the nodes. Now D is lesser alphabetically than D, so it comes to the left of D. A is alphabetically lesser than D, it comes to the left of D, whereas F is alphabetically lesser than J but greater than D, so it comes to the right of D. Similarly, N is greater than J alphabetically, it comes to the right of J, and then K is less than N, it comes to left of N, and X is greater, it comes to right of N. So these two are the examples of a binary search tree. Now what happens if we have one node which is alphabetically highest, let's say Z, and we have all the nodes which are lesser than Z, and they are given in a particular order that all the nodes are added to the left, which means every node that comes in is at the left of Z, then left of Y, left of X, so on. So if we have a decreasing alphabetical order of nodes, all the nodes will come to the left child. All the nodes will come to the left child. So this kind of tree, which is shown on the left hand side, is called as the left skewed binary search tree. So when I have to search a node, I have to keep on moving to the left child of every node unless and until we get the child that we are searching. So there are large number of operations that we have to perform. Similarly, if I talk about a right skewed binary search tree, that is a tree in increasing order of elements. So we have A, and then all the nodes which were greater were coming on the way. So they were added to the right child, not to the left. So this type of tree in which every node comes in increasing order forms a right skewed binary search tree. So when I have to find any element, we have to keep on searching to the right side, right child of every element. So this also involves large number of operations. So the solution is that we need to have a balanced height tree, because the skewed trees have a large height in the left side and a large height at the right side. So that we have a balanced tree, the solution for this is AVL tree, so that we have a balanced binary search tree, so that the search takes less time. So one of the solutions is AVL tree. So AVL is one of the most popular balanced binary search tree. It was introduced in 1962, and AVL is the name because it was introduced by three people, Edelson, Welsky and Landis. So is the name, which is from the initials AVL. So to know more about AVL, check out my next video. Thank you so much.